So we're going to spend 4 days in this packet. You're going to see this 4.5, and we're going to spend 4 days. And each day we're going to kind of have on the shorter side of a lesson, and then you're going to have time in class to get started on a worksheet, and then that worksheet is going to be your homework. I don't really like the book that much in this section, so each night your homework is going to be a worksheet. So if you're gone over the next 4 days, then make sure you watch the video, and then you already have what you need, okay? By the way, we're going to have a quiz over this probably on Tuesday, maybe Wednesday. All right, and I'll remind you guys of that, just putting it out there now. All right, so on this first day, I'm really just going to introduce you to this thing called U substitution. Okay, we could call it just substitution. I like to call it U substitution because that's the letter that we use. Okay, so if you look at this first problem, you can see, okay, we could do this problem. This could have been on the test. It would have been a little mean of me to put something like this on a test, because what you would have had to do is a lot of algebra to make this look like a polynomial. You would have had to square that out, and then distribute the 2x, and then do the antiderivative. And that would have been, you know, not really that pleasant. Okay? So we have this new method, and what we're going to do is we're going to let u, the letter u, equal a part of this problem. Now, if you read ahead, you can kind of see what's going on. But I want you to see the two things, the two main parts of this problem. Do you see how one of them is the derivative of the other one? Okay? Which one is not the derivative? The x squared plus 1. So that's what I'm going to let u equal. I'm going to let u equal x squared plus 1. Okay? So when I rewrite this problem, okay, in place of x squared plus 1, I'm going to write a u. So it simplifies the problem down, and it makes it possible for us to continue. Now, we do have an issue of some other stuff in the problem, and that is hopefully covered under du. So what we're going to do is we're going to take the derivative of this equation. All right, so there's always going to be two equations. One is u equals, and the next one is going to be du equals. Okay, and so we take the derivative of x squared plus 1, which is 2x. Now, I want you to write a dx after this, and I'm going to explain why. All right, now technically, when you take derivative of u, it's really du over dx, okay? Like it's really du over, dx. And then we multiply the dx to the other side, okay? But I'm not going to write that because what I've written it here, the way I did it first, is just a lot easier, it's more concise, and it's less writing for you to have to do, okay? So, but what you have to remember is du equals, take the derivative, and you always have to write dx after that. So the point here is that this stuff over here gets replaced with du. Okay, so instead of 2x dx, I get to just write du because they're equal to each other according to the second equation. All right, now one thing you need to know is that we started with all x's. And then once you do the substitution, we no longer have any x's left over. It's just u, okay? Now we're ready to integrate. So remember the integration symbol, and it used to be dx, but now it's du. Those are like the bookends to what we're taking the antiderivative of. So we are taking the antiderivative of u squared. And what would that be? No, not the derivative. The antiderivative.
1/3.
1/3. Yeah, it's so easy to get confused because we're going back and forth like we are. And then don't forget your plus c. So 1/3 u cubed plus c. So that's my answer in terms of u. And so, but if the original problem is in terms of x, my final answer needs to be in terms of x. So you got to do one more step. This is the easiest step of all, though. All we're doing is rewriting the problem, and instead of u, you're going to actually write x squared plus 1. And then plus c. So let me just recap these steps. And what I've written here in red and blue is the same thing that's typed out right here. Let me just kind of recap the steps. We looked at the problem, and we analyzed it, and we figured out what should u equal. Okay, and we wrote that equation. Then we said, okay, well, what is du equal to? And I did the substitution. Okay, from there, once you're all in u, then you get to integrate. okay? And then you do the substitution again. So it's kind of like setup, substitution, integration, substitution. And that's the process we're going to follow each time. Now, to check your work, which I'll go ahead and use green for this, we can just take the derivative. We've already been doing this. Anytime you have an integral, something you've integrated, if you take the derivative, you should get exactly what you started with. So in order to derive this, what rule do I need to use to derive it? This is going back to first semester stuff. The M&M rule, which we call chain rule. So, and because it's a function within a function. So this would be a regular M&M. It wouldn't be a peanut M&M, although we'll get to one of those in a little bit. So 3 times a third, that would be 3/3. We'd leave the x squared plus 1 alone. We'd subtract 1 from the power, and we'd go times, this is the chain rule part, the derivative of the inside. Now, the 3/3, that cancels to 1. And so if you see here, what you have is the exact same thing you had to start with, not including the integral sign and the dx, because those are like the bookends of the problem. Okay, that's how you check your work without a calculator. How could you check your work with a calculator? Differentiate the answer with your calculator. Can you integrate with your calculator? Yeah, we just went over a problem like this. This one would be even easier than that one. You wouldn't have bounds, so after the comma x parentheses, you stop there, okay? All right, so we're going to practice this again, and this is kind of one of those things that is weird, and then you start to get it, and then it becomes a lot easier, okay? It's just a strategy, so feel free to ask questions, especially like why did you do this? Ask those kinds of questions if you have them. So parentheses are going to be your friends. A lot of times what your u equals is in parentheses. Now sometimes you have no parentheses, but you could put them in. Where could you put parentheses in this problem? On the 5x, like that, right? What I've drawn here is the exact same problem as what we started. Okay, so see how the 5x is in parentheses? Let's let u equal 5x. And this really is the hardest part, is figuring out what your u should equal, and you're going to get better at that with practice, and I'll give you some hints as to how to do that. All right, so then what would du equal? Because now we're taking derivative. We have to have 2 equations. 5, and then what should you write after it? Dx. Think of this in a couple of ways. You took the derivative of an x, so you write a dx. Technically, it was really du over dx equals 5, but again, this is going to be a better way to do this problem, I think, long term. All right, so let's do the substitution. Okay, so I'm going to go ahead and write my integral sign, and instead of cosine 5x, I'm going to write cosine u, right? Now, watch this. Okay, so I took care of cosine of 5x. I replaced it with cosine of u. What else do you have in this problem? A dx, right? I need to get rid of that dx. So see this dx? I need to replace dx with something it's equal to. But this 5 is in the way, and it's not in my problem. So what could I do to this 5? I could divide by 5, both sides. Are y'all okay if I write that as 1/5? We could write it as du over 5, but just trust me on this. It's going to be better if we just write it as a 1/5. So because it wasn't 5 dx, it was just dx, you want to get rid of that number, okay? And so what you end up having over here in replacement of dx is a 1/5 du. So remember what I said, you start with all x's. Once you do your substitution, you shouldn't have x anymore. It should only be u. That's an easy way for you to kind of check your work and make sure you're on the right track. Now here's the best part about numbers. We've seen this before, but we're going to really use it like in this unit or this section. So see this 5 right here? See how it's just being multiplied? You can move it to the front. So let's do that next. And this is going to be a very common thing that we do. So next time, if I know that the 1/5 is going to be moved to the front, you could just do that in the beginning. I'll explain that in the next problem. So the 1/5, and so let me just go ahead and rewrite what I have. You want to do this because the 1/5 isn't making the integral easier. It's making it harder. So if you can kind of like get rid of it and push it off to the side, it's going to make the problem easier for you.
Does it not mess it up to have it?
So what we're going to do to take care of it is we're going to just do 1/5 times whatever I write next. You can do this with numbers only. I couldn't have done this with like an X or a U, but and this was one of the properties we talked about on the first day, and we have done this before, but this is a really important step to these problems. Okay, so now look at the bookends, right? The integral symbol and the du. What is the antiderivative of cosine u? Sine of u. Positive or negative? Positive. Very good. Okay? Don't write du. I integrated. The du and the integration symbol, they go away when you actually integrate, when you take the antiderivative. I do need a plus c, though. And then so my final answer is I'm just going to rewrite everything, but instead of u, I'm going to go back and put a 5x in, because your final answer really needs to be x, not u. U is just something we kind of do in the middle of the problem to make it like where we can, it's a strategy we use. So here's your answer right there. Now, I already said this, but it's easy to check. Let's say we messed up with the 1/5, or maybe we thought there should be a negative. You can check it with this next step, which is just take the derivative. Okay, so if I wanted to take the derivative of 1/5 sine 5x, I would have 1/5, and then the derivative of sine 5x would be cosine 5x times 5, right? Chain rule, M&M, not peanut M&M, regular M&M. And then the derivative of c is always 0. So see how the 5 and the 1/5 cancel? And what you have, that is exactly what you had to start with, in between the integral symbol and the dx. So that's how you know that you did it right. You could also check with your calculator, but this is how you check without your calculator. Okay. So looking at the next problem and thinking about what I said, anybody think they know what u should equal?
X squared plus 1.
Yeah, why'd you pick that?
It's inside the parentheses.
It's inside the parentheses. So parentheses are your friend. There are some problems that are going to be a little bit harder, but when you see parentheses, more than likely, almost every single time, that's what your u should equal. Okay, and once you write your u equals statement, next you're going to write your du statement. Okay, so what's the derivative of u? Well, what's the derivative of x squared plus 1? 2x, and what should I write after it? Dx. So it becomes a process that was kind of weird at first, then you start getting used to it. Okay, so here's my integration symbol again. Okay. And in place of x squared plus 1, I'm writing a u. And so it becomes u squared. And what you have to do is make sure that you replace the other things. Now, they're separated, but it's still just an x times dx. So you got to look over here and you got to say, okay, I have an x and I have a dx. But this 2 right here, I don't want that 2 there. So think back to how we did it on this problem. We divided by 2, and that created a 1/2 over here. Okay, so what you can do, watch what I'm about to do up here. You can go times, okay, and replace the x dx with 1/2 du, or knowing that you're going to move it, what we could have done as well, okay, which I'm going to encourage you guys to do, is just to go ahead and move that number to the front of the integral symbol. That's what you're going to do every single problem, so you'll get used to it really fast. So you can write it like how we did here and then move it in a separate step, or you can say, well, I know that 1/2 is eventually going to the front, let's just go ahead and write it in the front. Okay? Does that make sense? You're just trying to make it easy on yourself. So this 1/2 just gets multiplied to anything that comes after. All right. So we have our bookends. We have our integral symbol and we have our du. The antiderivative of u squared is 1/3 u cubed, right? And that's great. That's a good answer, but it's in terms of u. So we always have to go back to, okay, what letter were we starting with? We started with x, we got to go back to x. All right. It would be okay if you left this as 1/2 times 1/3. I would be okay with that. AP graders would be okay with that. But let's go ahead for today and simplify it. What is 1/2 times 1/3? 1/6. And then in place of u, you got to actually write down what is u equal. And this is where this setup right here really going to help. Of course, don't forget your plus c. I'm going to do all this work and forget plus c. And then you check your work by deriving. So I'm going to do this part really fast. 3 times a 6, that's 3/6. Keep the inside the same. Subtract 1 from the power times derivative of the inside. And so 3/6 times 2, that cancels out. And what you have is exactly what you started with, what's between the integral and the dx. So you know we did it right. All right, now, number 3. What do you guys think u should equal on number 3? It's kind of like number 1 a little bit. 3x. Okay, here's what I want to tell you. If you're using a pencil, go ahead and do this. If you're using pen, I want you to put your pen down and just watch. Okay, because we're going to, you can take that for what it's worth. So I'm going to write it, but just know that I'm going to erase something in a minute. So if you let u be 3x, what would du equal? 3 dx. And then what would we do with this 3? We divide 3 over to the other side. So look what you get next. You have a 1/3, right? You can either move it later or move it now. And then you have a sine squared u cosine u du. Do you know whose derivative is sine squared u cosine u? Is that one of our 6 trig derivatives? No. We're stuck, right? So when you get stuck, it means that you picked the wrong u. Okay, I've taught this many times, and this is I always like to go through this process. Because when you're doing this, you are going to pick the wrong u from time to time. And you need to know how to get yourself out of it. So this is what you do. You're like, I'm completely stuck, I picked the wrong u, so I'm going to erase everything I wrote here, and erase everything, and I'm going to start over. Okay? And I'm going to move this over a little bit here. So then we're like, well, what is u? It's not 3x. Could we rewrite, I like your idea of sine squared, but could we rewrite something in parentheses? Like, see how that sine squared 3x? Could we rewrite it as this?
So u is on 3x.
Yeah, so we're going to use sine 3x. Once I put those parentheses in, it becomes a little bit more obvious. Now, I'm still we may be thinking it's not obvious, but yeah.
What about the 3x and the cosine?
So let's see if it works out. We did it right. If we get stuck again, then we have to go back to the drawing board. All right, but I will tell you, it is going to work out. So if you're using a pen, feel free to write. Okay, so then du. I'm really going to run out of room here. That's okay. So du is going to be cosine of 3x, right? We're taking derivative times 3 times dx, right? And this is where that part gets picked up. It's right here in our du statement. But the 3 isn't. So what do I need to do with this 3? Go here. Okay? So if you're still like, I don't know what just happened, let me show you the substitution step. You can kind of get back in. Now, this 1/3, you can put it wherever you want in the problem, but it is eventually going to go in front of the integral sign, so you might as well put it in the front at the beginning. It's just easier for you. Okay, sine 3x, that's what we let u equal. So sine 3x squared, that becomes u squared. Now, all of this right here that I underlined in blue, cosine 3x dx, that's all of this right over here. We replace that with the 1/3 du. Well, I already have the 1/3 right here, so I can just put in the du. So do you see how the problem got much simpler? That is a sign that you're on the right track. So this was a harder problem than the one we just did. But it really starts with making sure that you have the right u. As you practice this, you'll start to pick up on patterns, and again, this is why we're not doing everything in one day. We're just kind of practice as we go. All right, so that's 1/3. Integral of u squared would be 1/3 u cubed plus c. And we would write our final answer as 1/9, right? A third times a third is a ninth. And then u, back to what we started with, is 3x. So your final answer is in terms of x. So you start with x, you do your substitution, you integrate, you end with x. And you could check this again by taking the derivative. I'm going to skip that part for now. All right, now, I'm just going to write a line here, and I'm going to do this next problem in green. Just highlight. Now, are there any parentheses in number 4? No. So how do we write parentheses? To the 1/2 power. Okay, once you put those parentheses in, it should be obvious what your u should equal. So what does u equal? 2x minus 1. So then du equals 2, right? dx. If you look in your problem, you have a dx, that's good. You don't have a 2, so divide that over to the other side. So you start to see, okay, it was weird at first, but it's a lot of the same things happen from problem to problem. Okay, so back to this problem. We have our 1/2, right? So right there. In place of 2x minus 1, we write u to the 1/2, and in place of dx, we write du. So we rewrite the 1/2. What's the antiderivative of u to the 1/2? So we need to add 1 to the power first. Y'all might have said this. I'm kind of having a hard time hearing today. That's 2/3. And then plus c. So then my final thing is go ahead and multiply these numbers. That turns out to just be a third because the 2's cancel. And then u is supposed to be 2x minus 1. And that's my final answer, which again, we could check by taking the derivative. Okay? So check your answer by taking the derivative. That's how you check your answer without a calculator. And I know it's confusing to go back and forth between deriving and integrating, but like you're only going to get better at it if you practice it.